What I would like to talk about today is vertex form for a quadratic equation. So vertex form for a quadratic equation, let's recall from the previous set of notes, looks like this: a, some number in the lead, x minus some number, quantity squared, plus k. If you're finding the vertex of a quadratic equation, and the equation comes to you in this format, actually, this is the easiest format by which to find vertex. The simplest way is just to read the values of x of the vertex and y of the vertex out of this equation. X of the vertex is exactly equal to the value of h that shows up in this expression. And y of the vertex is exactly equal to the value of k that shows up in this expression on the right. Let's have a look and see how this applies in this example equation below. We have y equals 2 x minus 1 quantity squared plus 5. So let's identify the values of a, h, and k. Take a moment on your own, try it. Compare the equation you have here with the general form of vertex form. Who is a, who is h, and who is k? So just pattern matching, just comparing the two, a, x minus h squared plus k, the quantity that is being multiplied by x minus 1 squared, this number in front, is the a value, in our case, 2. The number that's being subtracted from x, the number that's being taken away, x minus 1, our h value is 1. And the number that's being added outside of the squared quantity, plus k, in our case, plus 5, our k value is 5. So what is the vertex if we were to graph this equation? Well, the x-coordinate of the vertex is identical to the h value. The y-coordinate of the vertex is identical to the k value. 5. And so I can find the vertex just by reading off those two numbers. The vertex is 1, 5. Now let's try it again with this slightly different example. What is the vertex of y equals 3x plus 4 squared plus 6? Let's try and find the values of a, h, and k. Now this looks a little bit different from vertex form at first glance. And the big issue that I'm seeing here is that instead of having x minus a number inside the squared quantity, we have x plus 4, x plus 4. So to begin with, we're going to do a little bit of rewriting of this expression on the right-hand side. So that instead of x plus 4, we have x minus some number. So what do you think? What number could we subtract from x so that it's equivalent to adding 4? Now you may recall that subtracting a negative number is the same as adding. So I can think about this as x take away negative 4. So if I compare this now against the general vertex form, I have a 3 for my a value. I have a negative 4 for the h value, and I have a positive 6 for the k value. So what is the vertex? The x-coordinate of the vertex is exactly the same thing as the h from vertex form, and the y-coordinate of the vertex is exactly the same thing as k from vertex form. And so the vertex is the ordered pair x first, y second. No calculations required. So if you have a quadratic equation in vertex form, there are two graphical features that you can find without doing any calculations or algebraic work. The first one is you can decide if the parabola should open up or open down. And that, as always, is determined by this leading coefficient, by this a value, which is exactly the same no matter what form you're dealing with, standard, factored, or vertex. And the second graphical feature that's specifically nice if you're in vertex form is the vertex. You can detect the vertex right away. The vertex is equal to the number that's being subtracted from x and the number that's being added to x minus xv quantity squared. You just read that right off of the equation. Now I'd like to speak briefly about some of the advantages of being able to see the vertex and being able to see whether the parabola opens down right away without doing any calculations. So take, for example, this problem. We have 5 equals 2 x minus 1 squared plus 4. How many solutions are there? Now notice that we're not actually being asked to solve this equation. We're not being asked to say what the solutions are. The only thing that we're being asked to do is say how many solutions we would expect to get. So what I'm going to do is I'm going to sketch a very crude graph of y equals 2x minus 1 squared plus 4. And I'm going to do that very, very quickly by graphing the vertex and then graphing the rest of the parabola based on whether the quadratic opens up or down. So take a moment on your own. What would be the vertex of this equation? And would the parabola open up or down? Now, because this equation is in vertex form, we can find the vertex very quickly. The x-coordinate of the vertex is the number that's being subtracted from x. 1 is being subtracted from x. And the y-coordinate of the vertex is the number that's being added to x minus 1 squared, 4. Now, does this parabola open up or down? This parabola opens upward because the a value of 2 is positive. So I'm going to navigate now to the point 1, comma 4. That's our vertex. And I'm going to draw the parabola opening up from there. But how does this help me answer the original equation, which says how many solutions are there if I replace y with 5? If I go to y equals 5 on this picture now, and I look for all the points on this graph with a height of 5, I see 2 such points. One perhaps somewhere between 0 and 1, and another one larger than 1. I have 2 x values that would yield a y value of 5. So just with that step, I can say there are 2 solutions. There are 2 solutions to this equation because there are 2 values of x that would give me a y value of 5.